Hey, Mr. Dombowski.
Hey.
I have a question.
Uh-huh.
I keep seeing this word in chemistry.
Stoichiometry.
Stoichiometry.
Yes.
What is stoichiometry?
Okay, well, it's a necessary part of chemistry. It's whenever we have a chemical reaction, it's going to tell you how much is being made or how much stuff you need in order to make something.
How much is made
or
how much you need.
How much you need.
So that kind of sounds like a recipe to me.
It's exactly like a recipe.
Can we do this with a recipe?
Yes, as a matter of fact, I see one written right there.
Look at that.
Yes.
All
So
right.
we've got 2 slices of bread, 1 tablespoon of peanut butter, 3 tablespoons of jelly. Combining all that makes 1 sandwich.
Okay, I like me some peanut butter and jelly.
All right.
That looks good. Okay, so how many sandwiches with 24 slices? Well, that's easy.
Right. But we are going to demonstrate this with using dimensional analysis.
All right.
Okay, so we're going to start with our given. We're going to set up our railroad tracks like we've been doing, and our given is going to be 24 slices.
Okay.
Okay.
I know slices has to go on the bottom.
Right.
Okay, so where do I get a number or what?
So our recipe up here is a ratio of how much of everything we need.
Okay.
So we know 2 slices is going to be how much we need to make 1 sandwich. So and we basically made a
ratio.
A ratio, right?
Yeah.
So 2 slices of bread is what's going to go on bottom, and 1 sandwich goes on top.
Okay, so I just used these numbers from my recipe.
Right.
Okay? And then I know you've already taught me this. I multiply across the top, and I multiply across the bottom, and then I divide. 24 divided by 2 is 12. Now, I could have probably done that in my head.
Right.
Can I always do these in my head?
No. Is that
why you're showing me this now?
Yes. It's going to get more complicated from here.
And my slices cancel. Okay. Can we do one more with the recipe before we get into the chemistry stuff?
So let's look at how many tablespoons of jelly are needed for 36 slices.
Okay, so I'm going to make my tracks.
I can't do that one in my head. If you can, you're probably better at math than me.
36 slices. Okay, and I know slices has to go in the bottom, and I look up here to my recipe for the number. So that's a 2. And teaspoons of jelly is 3, right?
Yes.
And I went to that because that's what the question asked me for. Okay, so I'm going to multiply across the top.
So we've got 36 times 3.
Okay, that's 108.
108, and we're going to divide that by 2 because that's what we got on bottom.
Okay, my slices are canceling.
Slices canceled.
So that should be 54, I think.
Yep, 54 tablespoons of jelly.
That's a lot of jelly.
That is a lot of jelly. Now, before we move on, I want you to make sure you see our little recipe. This is like a balanced equation.
Ah, you're sneaky.
So that 2 in front over here, that's like 2 molecules of bread, quote unquote. 1 molecule of peanut butter. 3 molecules of jelly, making 1 molecule of sandwich. Okay,
so are these things here, you said those are ratios.
Right.
What kind of ratios are those?
Those are going to be molar ratios.
Oh, because these numbers represent moles. So molar ratio is the ratio of moles.
Right.
Huh. That's easy. Okay. Ratio of moles. So should we do this with some chemistry?
Yes.
Okay. So go ahead and get out your guide to practice. And let's look at the first example. How many moles of ammonia are produced when 0.6 moles of nitrogen react with hydrogen?
Okay.
Whew, I'm really glad I see an equation already written for me down here.
Right, and this one, is it already balanced?
Let's see. 2 n's on the left, 2 n's on the right. 3 times 2 is 6 h's. 2 times 3 is 6 h's. So yeah, it's balanced.
So it's balanced. So this is going to tell you your mole ratio. For every 1 mole of N2, we're going to have 3 moles of H2.
Wait, where'd you get the 1? There's no number there.
But anytime you have, chemists don't like to write their 1s. So every time you have a blank in front of it, that's a 1.
Okay, so this counts as a 1.
Right.
Okay. So for every 1, you have 3, and that's a molar ratio.
Right.
And for every 3, you have 2, and that's a molar ratio.
Right.
Okay. So I'm going to start with my known here, my given.
Okay, so
.600
moles
of
of nitrogen.
Does it matter if I put the nitrogen?
Yes, because that tells us what we're going to put on the bottom here. We have to have moles of nitrogen on the bottom now.
And so I look at the N2 here, and there is nothing in front, which is a 1.
Right.
So I put a 1 with that?
So put a 1 with that.
And it's asking how many moles
of ammonia.
That's this one, right?
Right, NH3.
It looks like I'm going to have to remember all these formulas.
So 2 moles of NH3 of ammonia.
Okay, and this cancels. And I got moles of ammonia, which is what I want. So am I done?
No, yeah, we're all set up. We just have to calculate.
Okay, so I multiply across the top. 1.2
right.
over 1, so that's 1.2 moles, and I have to put ammonia at the end, right?
Yes, NH3.
That's it?
That's it.
Okay, can we try one more just to make sure?
Yes.
Okay.
So, this one, we didn't balance it for you, so we've got to do our wrap first.
Mr. Domboski!
I know, it's like, I expect you to remember things. Alright, so, let's start by writing wrap underneath this, and we're going to find our total, or what atoms we have. What atoms do we have?
Let's see. I have Al.
Al, aluminum.
And I have 1 over here. And I have 2 over here. So should I put a 2?
Yes.
Okay. And then I have O. I have 2 over here.
Right.
And I have 3 over here. I think I have to go to 6, right?
Yes.
So if I to go to 6 here, I put a 2 because 2 times 3 is 6.
Okay.
And to go over here, I have 3 times 2 is 6. Okay?
Okay. So, is everything on balance now?
Yeah.
No. Aluminum's not.
2 times 2 is 4. Like that?
There we go.
Okay. So let's look at the question.
Okay.
The formation of aluminum oxide is from the constituent elements aluminum and oxygen. How many moles of aluminum are needed to form 2.3 moles of aluminum oxide?
Okay.
So I'm going to draw my tracks. I start with 2.30 moles, and it says aluminum oxide. I think that's this one, right? Okay.
That's it.
So I know moles of Al2O3 has to go on the bottom, and I pull the number, right?
Right, which is a 2.
And I want to know how many moles of aluminum.
Right. So we pull that from the balanced equation also, what we have in front of aluminum. 4.
Okay, so that's going to cancel.
Right.
And now I multiply across the top. And I get 9.2 over 2.
Over 2, because...
And that gives me 4.6 moles of aluminum. So these are kind of like recipes, huh?
Right.
For chemistry.
Yes.
So in order to get the, that much aluminum oxide, I need to put in 4.6 moles of aluminum in the beginning.
Right. Yes.
Cool. I think I got it. Let's practice some more.
Okay, great.